Welcome to day 9 of our programming course. Today we will be learning about control structures. We will cover sequence, selection and iteration in programming as well as conditional statements, loops and recursion. First, let's talk about sequence. Sequence refers to the execution of instructions in a linear order, one after the other. Each line of code is executed in the order it appears, which is the most straightforward way of structuring a program. For example, when you assign values to variables, they are processed sequentially. Like in this example, int x equals to 5, b int b equals to 10, and int c equals to a plus b. This is a simple sequential flow. Next, we have selection. Selection allows your program to make decisions based on certain conditions. In programming, we use conditional statements to select the path of execution. The most common ones are if, else, and switch statements. For example, in the if-else structure, if a condition is true, one set of actions will be executed, otherwise, a different set of actions takes place. Here we check if a number is greater than 0 using an if-else statement. If true, the program prints positive number, otherwise it prints non-positive number or negative number. Now let's look at iteration or loops. Iteration allows us to repeat a set of instructions until a certain condition is met. This is useful when we don't know the exact number of times an action needs to be performed. There are several types of loops in programming. The for loop is typically used when the number of iterations is known. The while loop checks the condition before every iteration. Finally, the do while loop ensures that the code is executed at least once before checking the condition. All of these help in repeating actions efficiently. Conditional statements are essential in controlling the flow of the program. These statements help us choose between different actions based on conditions. For example, the if-else structure allows us to check a condition and based on whether it's true or false, execute one of two possible code blocks. In this example, we are checking if a number is greater than 10. If true, we print greater than 10. Otherwise, we print less than or equal to 10. Now let's dive into recursion. Recursion occurs when a function calls itself to solve a smaller instance of the problem. Recursion consists of two parts, the pace case and the recursive cases. The pace case defines when the recursion should stop, and the recursive case calls the function again with a modified input. For example, in a factorial function, we keep calling the function with smaller numbers until we reach the base case where n equals 0. So why is recursion important? Recursion simplifies complex problems by breaking them down into smaller, more manageable subproblems. It allows for elegant solutions, especially when dealing with problems like sorting, searching, or traversing hierarchical data structures like trees. For example, the Fibonacci sequence is a great example of recursion. By defining the problem in terms of smaller instance, we can calculate Fibonacci numbers efficiently. To recap what we have covered today, sequence refers to the execution of statements in a linear, step-by-step manner. Selection involves making decisions based on conditions using if, else, or switch statements. Iteration allows us to repeat code using loops like for, while, or do while. Recursion solves problems by calling functions within themselves, breaking problems into smaller parts. These control structures are the building blocks of any program, allowing us to write efficient and logical code.